And that's how, NLP is different in terms of how we do machine learning. NLP is not machine learning, definitely not, because with machine learning you will not get to focus on the context of something, but you basically target in converting things into numerical form, and you find either logistic regression, either find a regression, or either find a classification analysis, right? In NLP also we do that, but that was a later stage. Now when I move into so these are like traditional NLP problems. When we move into deep learning aspect, right, NLP is again become more powerful. Why? So NLP has something like word to vec. If some of you have heard about word to vec or gensim, or if you have heard about libraries like gensim, or if you have heard about skipgram, cbow, what are these libraries? Is like a neural network that are already trained with some data, and what it does, it gives you the vector form of the sentences or words. Now if I give you one example, let's say I tell you that I saw a girl with a telescope. Now the word telescope, if I have to get the verb of the vector, the numerical representation of telescope, I'm not just doing one hot encoding. What we used to do in one hot encoding is, does anyone know? In one hot encoding, what do we do? Let's say if I have a sentence, I saw a bat, or I saw a bat, right? For something like this, what we will do, we'll just assign 0. Let's say for I, if the I is present in that sentence, I will assign 1, and rest of the words, that are 3 words remaining, saw, a and bat, it will be 0. Similarly, if it is saw, I'm putting it in the chat. Okay. If it is saw, in that case, first one will be 0, and the next one will be 1, and rest 2 will be 0. And this will give me the matrix, which doesn't capture any grammatical information, doesn't capture any information about the context, right? One hot encoding, bag of words, TF IDF, these are some of the very basic building blocks in NLP. But from there we moved into neural network, where what we did is we took Wikipedia, the complete Wikipedia data, let's say, right? Or it could be your, let's say, your database. It could be your graph SQL database. It could be a connected, uh, you know, connected nodes that has some information. So what we are doing is that in case of this vector representation that gives you an n-dimensional space, the vectors are, you know, based on their distance, they are telling us something. What is that telling us? That whether a word is how a word is correlated, or how a word is related to the other word, right? Or how a context is related to the other context. So somebody says that I went to buy pizza, I also bought a bottle of milk, right? If I have these information, let's say these reviews or something, let's say our customer feedbacks, and if I am training that data and getting a vector out of it, I will know that milk and pizza is occurring together in most of the cases. So I'll know as a vector, when I represent them into vector n-dimensional space, they are either, when they are similar, they will be positioned in the similar dimension, or they will be in other dimension if they are not similar. So the more far they are as a vector, they will be more different from each other, right? Now coming back to one of the request from Sandeep, that the today's search engines, right? uh, I would say, like, for any search mechanism, how does it work? So when, for a basic search, let's say you can build a model that is like a rule based, right? So it has done like something with an if else. So you do, if dog is present, you give me that sentence. If something like domestic animal is present, give me that sentence, right? I can do something like that, very basic search in a document. No, there is, you can use plain regex function to search it, right? Like in Python, in any programming language, if you do this, you will get the response, right? But let's say if you want to put some intelligence there, little bit ahead of that, and then you put a mechanism of probably finding things based on more complex logics, until you do not really think of using something like vectors, right? Till that, everything remains mostly rule based with the traditional programming aspect, right? I haven't really done a lot of research with the Elasticsearch, but when I know about search engines, so in 10 years back when Google search engine, so does anyone knows about like how does Google search when we search something in Google? Let's say I search the volcanoes in the world, right? So it will give me the list of volcanoes or the list of documents, right? So does anyone know how Google search works if I search something in Google? What happens? Okay, fine. I know that some of you already know, but okay, Vishnu is saying page rank algo. Yeah, that summarizes. So when you say page rank, right? If I talk about very basic way to get this is like, let's say you have searched the volcanoes in the world, volcanoes in the world. So you have 4 words. What it can do is it can search those words in all the documents that is present in the web, right? And it can check where the word is more frequently happening. Based on that, it can assign a rank to the documents, right? And it can give you the top ranked document at the beginning, right? So this is one way that is called term frequency, or let's say inverse document frequency, TF-IDF. In NLP, this is solved using TF-IDF. Later, when we move to something like vectors, so when I search something that volcanoes in the world, this complete query can be converted into a vector. Now, I'm not really searching the documents as in words that are present there, but what I'm doing is I'm trying to find the similarity or similar vectors in the world wide web. That is the corpus. So as in I have a cluster of documents where the more similar documents are getting converted into vector, let's say on the fly, and I'm checking how similar they are. I'm only representing those. In BERT or Albert like algorithms, what we do is although we have a lot of things in place there, I'm not going to discuss about but in very nutshell, if I say that what BERT does is it gives you an mechanism to train with lots of data. So it could be in Wikipedia data. So BERT already have been trained with Wikipedia data, and it has embeddings, and that's why they are known as PLMs, pre-trained language models. Now what you can do is you have large data set, you can also train it from scratch, convert them into vectors, keep it in your database, or you can have a vector DB, let's say. And when you search something, it becomes very evident that the query, that is the Q, and the D, that is one of the vector that is aligned more into your query and gives you cosine similarity score. Let's say the more the lesser the angle is, the more similar they are, right? So the cosine similarity score of 1, that means they are highly or completely matched. If it is less than 1 and then so on closer to 0, it becomes lesser and lesser similar. So that way you will get all the results that are similar to that. And you can also do, I mean, there you can mention a threshold. Let's say if it is 90% match, you will get the responses. And from there you chose the top K results, isn't it? Or you can do a 100% match also, in case where you need a lot of accuracy in your search. So this is where NLP is really helping you solve that problem of search engines. And I'm definitely sure that Google in 2020 or 21, they have also started using transformer based models for their so many search. I mean, it's not that Google search is only focused on one specific area, but there are so many search aspects that they cover, right? So there are so many, I would say, search aspects today that they are handled by BERT or transformer like engines. Okay, so I mean, I kind of give you an overall idea, but if you have any specific questions, let me know. I'll move ahead.
That
All right.
really helped. Yeah.
Yeah.
Yeah, that really helped. Yeah.
Thanks, Sandeep. Okay, sentiment analysis. So in NLP or Spark NLP, you just import the Spark NLP library. This is an hidden library, but normally it is like it does all those things that you need to do for you know, for let's say converting things into certain forms. It has so many other like modules like pre-trained. So one of the things is like this: they have already trained some sentiment model and they have kept it as in Spark NLP library. So I'm importing that Spark NLP from pre-trained dot pre-trained, named this pre-trained model. Just giving you all of you a sample. I'm not saying that you will only have to use pre-trained model, but it is a sample. What is this Spark NLP dot start? So underlying any Spark engine, right? What is the core of Spark is called RDD, resilient distributed data. I mean, although this RDD name is very like, you know, in short, it sounds like, oh, so it is just 3 word. But if I, it's like a zipped word. If I expand it, takes, it basically talks about the whole Spark thing. So resiliency means that it provides you that the resiliency of running things which are like, you know, on multiple clusters, right? And distributed is basically telling you that things are running on multiple distributed computing. And then you have data, that is, as you know, that it could be any data, structured or unstructured data that we are running. Now Spark RDD takes care of all these things, but not necessarily that it will be always able to convert your data to a data frame. So for that, some Spark has introduced something like Spark data frames. Okay, so like in Pandas, we have Pandas data frames. Spark also has data frames. We will see some examples on that. Okay, but ultimately, how does that get converted into data frame? Using RDDs. RDD is the primary engine behind Spark. Okay, it has something like DAG, directed acyclic graph. So some of you who are like already working on solving graph related problems, DAG is the primary reason why Spark is much more faster. Now the DAGs are not really used um, for targeting any data. I mean, data as in here, the DAGs are the nodes. So for any directed graph, there would be edges and nodes, right? So what is the node here? The node is the cluster. So when I, let's say, I mean, I'll ask one basic question. If I take a if I take a sentence, something like, you know, let me put it in the chat because I don't want to bring another notebook here. So I saw a player who is playing in the ground. Okay, some sentence. He is a good player. Okay, so now let's say the next sentence, which is he is a good player. The first sentence is that I saw a player who is playing in the ground. Next sentence is he is a good player. Now let's imagine that I have two machines. As in the cluster, if I put this, I saw a player who is playing in the ground in one machine, and I tell that machine to do word count. So that will tell me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the word. 10 number of words are 10, right? In the second machine will give me he is a good player, right? So I that will give me 1, 2, 3, 4, 5, right? So first machine I'll get 10, second machine I'll get 5. How do we know? Like, it has to happen in very less time. So imagine if you have 10,000 data, 10,000 lines like this, and you have to find the unique words that are present, right, in that 10,000 lines. Now 10,000 lines are like for one machine, and let's say you have two machines, both are having 10,000 words, so 10 10 20,000. So both are processing in same time and getting you some results, and you will have to combine them on the fly, get the count, isn't it? So the DAG scheduler, or directed acyclic graph, which is the core of Spark RDD, that helps you know the task that is assigned to node 1 and assigned to node 2, assigned to node 3, get the output from node 1, combine it, and give you the final count. It is not the count that you are looking for different machines. You want 10 different outputs, right? You want one output. You have given one document, large document, split it into two 10,000 two documents, or like two partitions, as I mean, if I say in Spark language, two partitions, they are distributed into two nodes. Imagine 10, 100 or thousands of nodes, right? So it has to be done in very fast manner, that all the nodes at the same time able to process it, give you the output, combine the output, give you the final output, a final result. This is where Spark is much more faster than Hadoop. In Hadoop, MapReduce also does work in similar fashion, but it takes time. There is something like HDFS. You take the In Spark also we can store the data in HDFS. It's not that we'll have to use a local disk or a cloud, but we can use HDFS. But the thing is that in case of Spark, these DAG schedulers, DAGs knows that where the data resides and which node is currently processing what. That way it reaches to that node faster, combines the results, and gives you the final output. Coming back to NLP again. So this pre-trained model, it takes a, let's say, sentence like Harry Potter is great movie, and it gives you the result that is a positive. It is a positive output, right? Similarly, if we take about NER, so I already talked about little bit about NER. Let's say Harry is a person, Ron is a person, Hogsmeade is a location, right? So Harry and Ron met in Hogsmeade. This is the let's say sentence. So in that case, the NER is telling me that it is a person. Entity type is person. For Ron, the entity type is person. For Hogsmeade, entity type is location, LOC. Using Spark NLP, you can just import this and get output like this. So B person, I person, O, they are like different representation of the output. I mean, they basically tells us that what kind of entity this is representing. So generally with entities, what happens is, let's say if it is a large entity, John F. Kennedy. John F. Kennedy could be a person name, or it is an airport, name of an airport, right? So John, in middle you have F, and then at the end you have Kennedy. So what happens that in entity recognition, we train the data set with something like before, in and out, right? So we basically define which word has to be before, which is inside, and which is outside, right? That way we'll have, I mean, not more than 3 words. We generally take 1 to 3 words to define as an entity, and I'm talking about the trained data set. So this is giving you B person, I person. So the first and second, we generally get B and I. In this case, Harry and Potter. Okay. So I, and so it is telling us that this B person is part of, or I person is part of the first. So the beginning is here, the first word, and the the second is I, that is Potter. If I have another name, other last name, then it would have got O. Okay, for everything else it would be O. Let's see about another example like spell check or spell check correction. So some of you might have seen in when you type in Gmail today, you type something, hey, so somebody has given you an email and you are responding. So nowadays it gives you a sentence already, right? You don't need to type, making you lazy. But the thing is that it is making you less creative, isn't it? Sometimes what happens that you're typing, hey, thank you for your email, I'm writing about this, and then the next sentence is already there, so you just type tab, it will fill the word, isn't it? So um so that way what happens that that helps you type faster, but the problem is like being less creative. I mean, just telling on this term in term of you know the side effects of using NLP. But yeah, I mean, normally this is how it is for any sense, right? This is how it is. So the thing is that how does that be done, right? If you have to predict a given word, we have to predict a sentence given a word, or if I have to predict a word given a sentence, right? In NLP we have something called ngram, which is the traditional NLP technique, and it uses a conditional probability based model. Okay, so I'll explain that little bit, but before that, I see a question here. Beginning, okay, what does B and I mean in the output in the last slide? Beginning and intermediate. Yes, Bhavik, thank you. That is the beginning and intermediate of the word. So as I said, like Harry Potter, right? What is the beginning? Harry. Harry is the beginning of the name Harry. Potter is the intermediate or the next word. As it is like full name, you are putting with a space. It is identifying them with separately and also telling us that the beginning has another word that is intermediate. Otherwise, it will not be tagging it as a B. Okay, it will be just like an entity. Yeah, it has a boundary, yes, inside and outside. So if I have John F. Kennedy, when I have three words, so in that case, you will have B, I, and O. Okay, B, I, and O. So if I have two, I mean, if it is a location, so in this case, it is B person, right? It says B person, as you saw in the slide, B person. In case of location, it would be BLOC. So if it is John F. Kennedy as an airport, right, it would be BLOC, ILOC. Okay, it will be tagged like that. Clear, everyone? Any questions? So I was into spelling check. Yeah, so that's how like spell check also works. I mean, there are many things that we'll have to do in spell check problems, like getting into um, something like probabilistic model, something like you have to train with certain things that tells you that this word occurs with, most of the times the sentences occurs with this word, right? So in that case, you will be able to predict the next sentence. So that is known as next sentence prediction. Spell checker probably can be solved using a dictionary, or you can have again a prediction. So most of the times cat is spelled as CAT only, right? It is not spelled as COT, right? So if you are training your model with the correct spelling and the wrong spellings that are mostly happens, what it will, the model will learn about the correct spellings, and it will be able to predict the correct spelling whenever you are typing incorrect. Grammarly is one of the great examples today, right? Okay, moving ahead. So I already given you some background about what is happening in the backend, but let me, so I have given you the pre-trained models, right? So let me just quickly tell you the steps that are happening. So first thing is that Spark NLP.start, that starts a new Spark session if there is not one, and returns it. So the thing is that whenever we run things in Spark, first and foremost thing that you'll have to do is you will have to initiate a Spark session. The Spark session actually ensures that you are running things under Spark engine. Okay, the next thing is that I used a pre-trained pipeline. Pre-trained pipeline is nothing but that loads the English version of explain document DL pipeline, the pre-trained pipeline model, and the embedding that it depends on. So it is an already trained model. It has the word embeddings. It has already knows that these are the context for sentiment. There is a TensorFlow also initialized within the same Java JVM process that runs Spark. The pre-trained embedding and deep learning models like NER are loaded. So models are automatically distributed and shared if that are running on clusters. So as I talked about some concepts like DAG, right? So clusters comes into picture when you have, let's say, multiple nodes. Multiple nodes really, I mean, they are basically getting distributed tasks, right, among them. Next thing is the annotate. So annotate call runs on NLP inference pipeline which activates each stage's algorithm, tokenization, POS, etc. You would not see in that code. It is completely wrapped. There is only a module you will see here, pipeline.annotate. This annotate takes care of these some of the NLP tasks like tokenization, POS tagging, and everything. The NER stage is run on TensorFlow and applying a neural network with bi-LSTM layers for tokens and CNNs for characters. So, bi-LSTM, or I would say long short-term memory. Sometime back, I was like, I was just checking like how, I mean, 2-3 years back, I started with RNN and LSTM, but the thing is that just a year back or some time back, I was checking some of the YouTubers. They have put some videos on RNN and LSTM, and they have basically compared this model with Gajni. Some of you know that movie Gajni, and if you haven't seen, like, it's like in person who forgets things in an hour or something. I also don't remember exactly, but long time back that movie came. But these guys were comparing RNN and LSTM with that. So that Gajni, or the person that he forgets things, I mean, he only remembers things that happened 1 hour back. So he writes down on his body or on the wall or some everywhere. He writes it so he can remember after 1 hour. These RNN and LSTM modules are something like that. So it has a way to remember things. It has a technique to remember things, forget, get, and there are something like memory cells. So now this helps us, what to do is like to preserve the context, to preserve the context. So if I have to understand, I saw a bat, I'll have to know what I have told before. I have told like I went to Arizona forest, just for an example. Right? I went to Arizona forest, I saw a bat. So now I have the context, and it is now fully understandable that I am definitely, or the probability is more towards seeing a nocturnal bird, not a wooden bat. Correct? Okay, I know that I'm giving lots of information, but this is how it is, guys. In 1 hour, I can only try to make it very simple with the realistic examples. But now here, this we are using by LSTM. So LSTM is like certainly little bit advanced version of RNN, where we are using bi-directional. So left to right context, right to left context. We use by LSTM in case of this pre-trained model, which is zipped in Spark NLP. You don't see any code here. The things are already taken care in this pre-trained pipeline. Okay. So next thing is the embeddings that are used to convert contextual tokens into vectors during the NER inference process. And the result object is plain old local Python dictionary. Okay. So I'll quickly talk about, run over the key concept, that is like using a pipeline of text. So that is like the document assembler, and then you do text document, then you convert them into sentence to a like documents to a sentence. From sentences you get tokens, that means words. So you convert a document into multiple sentences. You convert the sentences into multiple words, that is called tokens. In NLP they are known as tokenization. Now after that you do normalization. What is that normalization? You basically find out if there are any spelling errors, or if there are anything that is having a lot of space, any punctuation things. All these things you basically remove, but not full stops. If you have any, in case of deep learning, right, embeddings, we don't really worry about punctuations. Like we don't remove punctuations. Basically in traditional NLP we remove lemmatization. We have something like lemmatization, stemming, then removing stop words. So we don't do that in case of embeddings when we do embeddings, because punctuations also carry some meaning there. That tells us where the sentence ends. Word embedding, so from there we get a word embedding. We train the model with a neural network and we get the weights. Instead of final output, what we do is before the final layer we take out the weights from it. Okay, so when we fit the vector, so let's say I have trained the model, I have fed into this, I have converted things into feature vector. So guys, as I'm going through this, I know that some of you might be very beginner with machine learning. Some of you may know some machine learning, deep learning. That is advantage. Some of you also know Spark or big data things. There are so many combinations. I mean, these are like vast areas, technical fields. So if you are not understanding the some of these concepts, that I'm not really going deeper, because this session is not really focused towards one specific area. So I mean, really, with the time that we have, I can't really go in specific area, but if you have any questions, put it in the chat, I will look into it and answer. Okay. Okay, so as we mentioned before, this transformer, so the thing is that when you do a fit is basically a large vector that you have to fit into a model. So what we do is, in any machine learning, deep learning aspect, so first thing is that we fit that vector into the model, and for that we use fit. There is something like document assembler that transforms at the first, and then it basically creates a document type like annotator type. And as we mentioned before, this transformer is basically the initial entry point to Spark NLP or Spark data frame. Then its document column is fed into sentence detector, and then we do the tokenization. So the annotator, something like, it looks like the input columns with the sentence and sentiment score and the actual sentence from where we get the data. Okay, the resources, it's a trained ML model, trained deep learning network, dictionaries, embeddings, rules, and pre-trained pipelines that are being used as a key concept here. Okay, putting it all together, you import Spark NLP, Spark NLP dot annotator, Spark training import dot import the other libraries that are from training data. And what you do is, first you initiate the Spark session. Next is you create a data set reader, or the RDD, I would say, the column reader. And we are using here BERT embeddings to convert everything to a vector. So BERT embeddings is like, you can use anywhere. I mean, it's not like you have to use Spark NLP. You can use that for converting any sentence word into a vector. Okay, and then what we are doing is we using NER tagger that will tell us that what sentence, which token, and what is the label for that, right? And then we will be fitting into a training data. That pre-trained model will give us the named entity recognition or the NER outputs for that. Okay, cool. Already it is like 11:49. The session was planned for 1.5 hours. So I have 10 minutes, but I want to kind of go through the lab notebooks. But any questions before that? Any questions before that?
Hello, I have one question. So
Yes.
when it comes to pre-trained models, we can pick any pre-trained models that is available on Hugging Face or anything, or we have to only use the pre-trained model that comes with NLP Spark.
You can use any pre-trained model. Okay. NLP Spark is a library. So the libraries are not restricted really to, you know, use multiple things together. There is no restrictions, but yeah, you will have when so I'm it's like, I'll tell you. So let's say there's a steel making factory, and they want you to put the raw materials inside the steel factory. So they are telling us that it doesn't matter how you bring the raw materials, by a truck, by plane, by anything, any means, and it doesn't matter how you feed in to the actual blast furnace, but while you put it, the form of the raw material should be same regardless of wherever you bring it. So Spark NLP is helping you to put that pipeline. Now, embeddings. word embeddings and the pre-trained models are kind of, you can say, the vehicles that helps you put things together. Now you can use Spark NLP based, or you can use Hugging Face based pre-trained models, not a problem. But ultimately you will have to ensure that what you are feeding into the model is going into the sometimes, you know, most of the time what happens that you get dimensionality problem. So you see that it is not fitting into the model, or the fit error, model fit error. So those things happens because your model, what it is expecting, the dimension of the feature or the matrix that you got at the end while you feed in, before you feed into the model, it's different. So those things are kind of, you'll have to take care. Till that, whatever you are doing, it is your way of, like, you basically build the pipeline. It doesn't matter how you build the pipeline, right? So NLP Spark is already having some ways to build the pipeline, and they are not different from traditional NLP. I'll show you some examples, no worries. So I'll go to that my
Okay.
notebook. Yeah, I hope that answers a little bit, Kushak. Uh, yeah.
You can share the code link for collab.
Yes, Vivek. I'll share it. I think I have uploaded it in the GitHub also. So let me put it from there. Because what happens that if I share the collab, everyone will try to run that. Instead, what you can do is, like, I mean, the best practice is copy it into a local drive, and from there you can run it. So I'll not take that risk of, like, explaining everyone. Rather, what you can do is go to this GitHub link, download that, and or you can directly open it in Collab if possible, and save it into your drive. Save it into your local drive. There is an option in open in Collab, save it in local drive, and from there you can run that. Sharing my screen again. So although you guys can look at it, but I'll tell you one thing that just now one of you have asked about, how do we set that. So if you look at this assembler, right, there is something like document assembler. These are from John Snow lab. They have in Spark NLP library, they have combined, or they have built these modules. But if, like, sentence detector, they have built this. Like tokenizer, they're they're using their own tokenizer, but it doesn't mean that all of these normalizer, lemmatizer, tokenizer, sentence creation, assembler, right, all these I can use mine also if I want. But as these are, like, I would say in a Spark NLP pipeline, this really fits. So you see at the end, this is a fit. So this helps you fit the whole data set into one single numerical form, and that is what is important. If it is not fitting well, you will not be able to fit it into your model, right? So I have taken a very basic problem on this notebook, that is classification and regression, which most of us know. I have not
Can
taken
you increase the font a bit? Increase the font.
Yeah, Vivek, let me do that. I don't know if
I think Control Plus will work. Control Plus.
yeah, that I don't want to do that, but yeah. Okay, I did not want to do that because that sometimes other things also becomes fine. How is it now? Can
Yeah,
you confirm?
okay.
All right. So the first thing that you see here, that I have pip install command to install PySpark 2.4.4, and the next one is installing SparkNLP, which is a open source library by John Snow Lab. Okay, so once you run this, it will do the installation of these required libraries. Okay, so if you guys are running it, you will not need anything. I mean, you can go to runtime and run all, but it is important that for now, instead of focusing on running this notebook, I will explain it and you guys can like get some of these concepts, right? Given the timeline that we have, I'll go through this notebook. Any questions, or if that is fine for everyone?
Yeah, that's fine.
Cool. So there is something like make dir, so that will create a data folder here, okay, in my local drive. And you see here that it is using a mini news group. Okay, it's a classification problem that we are solving. Mini news group has like something like any folder wise data. So that you see here alt atheism. So you will see the news group has collected different news articles, right, with a different folder and file names. For each group there are many files that are placed here. Okay, that will be automatically download from here. So you don't need to separately download, keep it somewhere. Okay, so now mini news group, once you download, we extract it, and then what we are focusing on, classification and regression problem. So this is the like most common task in machine learning. In NLP, like, although what we do in NLP is like we focus on some of these aspects of tokenization and getting the things ready for training the model, but ultimately it is like, I would say, not core NLP problem. It is an NLP with machine learning, this particular problem set I'm talking about, because classification cannot be, or regression cannot be a NLP problem, but it is more of focused on machine learning problem, right? So here I have imported some of the libraries like PySpark, SQL functions, PySpark. So PySpark, it has one advantage, that if you go to this PySpark SQL, you will see so many functions that it gives you or provides you. Go to the PySpark documentation and you will see PySpark SQL modules. I mean, why I'm just giving you this understanding is, there are libraries that you may not understand what it is doing. Can go to that module and you can read about what a specific function is doing. Okay, so I have imported PySpark SQL types import star, that means everything. I have imported SQL functions as expression, and then I have SQL functions import row, and there is a ML pipeline, Spark NLP. From Spark NLP, I have imported document assembler and finisher. Spark annotator, I have in Spark NLP dot annotator, I have imported everything. Now this will help me shape the data. So first thing is that regex function, compiling the header pointers. So if you see here, this I will run and pass the path of the files, get the lines from each file that I have kept in this data folder. So data mini news group star means everything that I'm reading from it, right? And I form a schema out of that. And next thing is that I create the text. So if you see here, this will give us the text that we have into the data set. Okay, you see here the data frame that has string and text and news group as string. In Spark, I'll have to point out here one thing, that how do we create a data frame in Spark? The statement is create a data frame. Okay, and one more thing, that we use a Spark context whole text file, and then we pass the file or the data set here. Okay, I will tell you one thing, that when I talk about RDDs, right, I think I have kept a very basic notebook. I don't know if I have that. Yeah. So if you look at the Spark RDD, right, how do we create a data frame in Spark? Normally, like we start a Spark session using Spark context. So from PySpark import Spark context. This is another notebook. I'm not now going to share this, but just for example, when we get the Spark context, right, this Spark context is everything. That basically helps you get created with the RDDs, resilient distributed data set. So RDD, now in Spark, let's say I have a data 1, 2, 3, 4, 5. This is a list. I can create a data frame by just passing dist data sc, that is the Spark context dot parallelize, and I pass the data. It could be any list. Once I pass it, I can just print the data. In case of pandas, we print it like df.head, isn't it? In case of Spark, it is df.collect, df.show, df.display, whatever you use, only those are supported. Okay. And so now you see that it has got converted into a data frame. Instead of parallelize, I can use create a data frame also. So here in this case, the syntax is create a data frame. So the Spark, what is Spark here? Spark is the Spark context. Okay. Create data frame is the module that is helping us pass the data set and converting everything to a data frame. Okay. So here, if I do text.show, I think I should be able to see the data. Okay. Can you see here, guys? Path, text, and news group. So it has, what is done is like it has read from each and every file from those data set and some displaying the text data from that, and what is the news group it belongs to. Okay. Then I do group by, and I group by based on the news group that they are belonging to. Okay. So you see here now this becomes every sci.made, sci.space, electronics, atheism, autos, motorcycle, everything is like into a one, all are grouped into categories based on their categories. Okay. So now I print text.first path, news group, text, which I showed here, right? The same thing that I am printing here. Okay. Next, what I do is I create the pipeline. The pipeline that takes, what it does, it first does a document assembling, then it creates the sentences, input columns and output columns. So input is the document I got from here. So you see here, I have two things on each of these functions: sentence input, set input call, and set output call. Set input call, set output call. And there is a function that is document assembler, sentence detector, tokenizer, lemmatizer model, normalizer. Okay. All of these are taking input from the previous one and getting into the next one. Okay. So if I give you one example, in this case, the sentence detector is taking input calls as document, right, which I got here. And similarly, in the next one, it is taking the sentence, which I got here. The next one, lemmatizer, is taking the tokens, which I got here, the output from the tokenizer module. So the pipeline is like next after next, we are feeding into a channel, right? And finally, we are getting the normalizer, which is basically taking care of removing some of these, specific patterns from the data. And after that, we get the clean data, right, which we will be using for processing. So if you see here, process data is pipeline.transform text.persist. Persist is nothing but helps Spark to cache data and to have faster processing. Okay. And then what we do is we print the processed count. Okay. So that is telling us that are 2000 number of documents. Next, what we do is we create a bag of words feature, which is by using this module. What we are doing here, we are importing from PySpark ML.feature count vectorizer and IDF. So TF IDF and count vectorizer nothing but some vector formation models, or you can say like feature extraction modules in NLP. Count vectorizer equals to count vectorizer, passing the input call as normalized text that we got earlier. Output call is TF, and min df equals to minimum data, a minimum document frequency is 10, right? So we are feeding in that and getting the bow pipeline output or bag of words model outline output. So you are getting bows at the end. So this is basically the process data, right? If you look at this bows dot limit to pandas, you will see something like this. So everything now, the TF IDF is anyway getting the term frequency, document frequency multiplied. I mean, basically the number of times a word is occurring, and we are converting everything to a TF IDF. That means everything to a vector. Is everyone getting this till here? All of you? Okay. Next thing is that we are using regular expression feature to basically do a match, and what we are doing is we are finding the patterns like alien, cosmic, quantum, dimensional, all these things from the text document. Okay. Regex is a library that helps you find things mostly in textual data, and it could be a numerical or alphanumerical alpha, right? So everything that you can have your own customized regex function that helps you search things into your text. So what we are doing is we are basically using this regex matcher that finds the data and normalizes the text that we don't need or some of the things that we don't want into our data. So I'm just quickly from here, I'm moving to the next group. Now you will see that what we get is news groups and their regex. So from here, we are getting alien, dimension, alien, quantum, size space. We are getting cosmic, all these things, right? So there are few ways in which these can be turned into features. You can create binary features. In other words, the value is 1 and any of the regexes match. You can also use number of matches as feature. Okay. It doesn't matter like how you do the feature. So next thing is the feature selection, where what we are doing is using a stop words remover. From the normalized text, we are filtering and removing is, and, the, this, that, all these words which are highly frequent, doesn't make a lot of sense in classification or regression problems where meaning is not that much of in focus, where we are not really looking for the context, but rather than finding some patterns. So next is we are using count vectorizer to input the filtered columns, and output is TF, that is the term frequency, and output call is TF IDF. So this is now the pipeline becomes assembler, sentence tokenizer, lematizer, normalizer, finisher, stop words remover, count vectorizer, IDF. So finally, what we are fitting is the vector that we got by doing the count vectorization of the whole data set.
So far, Energy, that looks like this much, like NLTK also has these capabilities, right?
Yeah, all traditional NLP has these capabilities, but
Okay.
NLTK doesn't do in this fashion.
Okay.
NLTK doesn't do in this fashion. We are using SparkNLP for building this pipeline, which matters a lot because this is the pipeline that is running on Spark.
Right.
We are not running it on normal CPU engine. It is a Spark RDD.
Okay.
So what happens is, let's say everything that when we like we can't even we don't think in this way that things are running in backend. Let's say when you do vectorization or when you do tokenization, right? So there is a task that is running. What it does is, like, if I have to find the tokenization, basically, let's say if it is based on space, if I think about one sentence and then I find the spaces in between, and based on that I split the sentence into different words, right? This is one task. And then once I finish it, it goes to the next task, that is feeding in those words into, let's say, TF-IDF model. But what we do in Jupyter notebooks or generally in the programming is we feed that into to the next set, which is not really linked in such a way that how Spark is basically linked. So the task is passed to the next layer and then so on in a very efficient manner. That's where the speed and also the efficiency comes into picture. The power of Spark comes into picture. Otherwise, you will feel like, okay, I'm doing the same thing that I used to do in NLP. It is by the looks, you will not see any difference, to be frank. Okay, next thing is that you do modeling. Here I have used naive Bayes classifier. So you can see the naive Bayes classifier. I'm not really going to explain naive Bayes classifier, but finally you will get an output that will give you the prediction here. Just a minute, I'll go down. Yeah, you will see the evaluator, that multi-class classification that tells you that what is the document, which class it is belonging to, right? And the F1 score for that. So this is a very documented one. I mean, I have taken it, borrowed it from some book, but yeah, you guys can go through it. It's as it is documented. There is not much explanation that is needed, right? So as the time already have, I see a lot of folks are already like started leaving. I see only a couple of folks left. Any questions, or how did you guys like the session? And please provide your feedback, and thank you so much for attending. I have already shared the notebook. If you have any questions, do reach out.
So first of all, thank you for this session. I had no idea about Spark NLP and Spark in general, and it could be a very beginning stage for me when it comes to Spark NLP. I have one question which is related to infotainment system domain. Infotainment system domain means the system that we have in Mercedes or Audi's cars, where we are planning to come up with some solutions using NLP. It is at very early stage at this point, but I would like to take your feedback whether using Spark and NLP or what you have discussed in today's session in infotainment system or the embedded system would be a right direction to look forward, or to do some kind of POC, or you would suggest to go with traditional NLP related stuff.
So,
and I have a small disclaimer, sorry. I have a very limited knowledge about the embedded aspect of the infotainment, and I'm also learning as part of this. Thank you.
Right. So I think that when you talk about infotainment, Kushagra, that more of comes into the domain of IoT devices, because I think there are so many, I would say, numerical data that comes from that. So it's more of not NLP, but I would say machine learning or deep learning aspects comes into picture. Unless or until you collect some information. So generally, like something is in verbal, right? Let's say somebody is speaking, somebody is like talking something, or somebody has written something, or some data that is collected as in textual information. Then NLP is really like something that you should think of. But as in,
yeah, we are moving towards the voice command, the natural voice responses.
okay, I got it.
Yeah,
I got it. So there is something like speech to text or speech NLP, right? I mean, speech to speech. You know that some devices like Alexa. So NLP is a great solution for that in terms of it has so many modules, like deep speech is one of the very powerful modules. I actually work in that. I'm leading a team of that kind of devices. But the thing is that as in infotainment system, there are so many inputs that may come, like as in or outputs that may come. So if I am asking like turn on the lights, or let's say open the door, something like that, so that goes as in command, and you definitely need to have those voices recognized as part of your modules. So I'm not sure that what is the exact problem that you are trying to solve there, but that will give us the context that how you can approach to such problems, right?
Hi, NLP. As you rightly
Yeah.
mentioned, definitely the first thing is speech to text, and then there's a pre-trained model. So for because my company also does the exact same thing, infotainment systems for for cars they build, but that's a different division. because that involves hardware. So they train this NLP model and transfer that on the firmware. So specific, and these boards are very specific. They come from multiple specific companies. So this NLP, the approach is the same, but the thing is there's additional step of speech to text, and then it's all the same NLP. Sorry to barge in. Sorry.
No, thanks for the input, Vishnu. Absolutely. So see, everything that we do today with speech, right? Speech related problems, you will have to convert them into text. You must have to. Otherwise, there is no analytics. And there definitely NLP is something that speech to text or text to speech. In today, when you think of Alexa like devices, when you say something, let's say turn on the light, the voice goes into the device, it gets converted into text. From text, it basically looks for the instruction, let's say the rule book, and it knows that this is the action. Once it performs the action, it tells you, like, let's say if it gives you a response that I have turned on the light, right? So that is again getting converted into a speech, the text to speech, and that is happening in very less latency or very less time, right? So all that today speech to text or speech to speech modules are working in this fashion. It has to go through the text conversion first. So the transcription modules are not so accurate, but as I talked about deep speech, right, something that helps you convert things into text, right? And on that text you can do a lot of analytics. So NLP will again come into picture if you, I mean, not only that speech to text module, but let's say on the text data you want to do so much of, like how many of people are using this feature, let's say, right? And what is the command that they mostly are using? If these are the insights I am looking for with thousands of infotainment devices, I would be able to know that by doing analytics on top of that. So that is text analytics after doing speech to text. And this needs a lot of training, as Vishnu has pointed, right? I am sure any organizations, whoever is doing it, there is no way to, you can have a pre-trained model, you will have to fine tune it, and you will have to ensure that it understands your commands, right?
Yeah, thank you, Indrajit, and thank you, Vishnu, for answering my question.
Thank you, Kushagra. You probably can have to do, you can do more exploration on speech to text kind of papers, and you will get to know more on that. I mean, considering like we have limited time, but yeah,
so actually,
that's how
I
you
have to
can
come
explore.
up with a different kind of solution itself, the features that are not currently existing, but we might pitch it to the customers that would you like to have these kind of features using NLP or machine learning or any deep learning kind of stuff. And we have to do a lot of paper reading, and we have to come up with a lot of
Yes.
POCs, and then we have to find up a feature that we can develop and deploy.
Yes, no, that's the approach, Kushagra. You have to experiment with the data, and also you have to experiment with the use cases that you have. The models and things will automatically, you will find out like there are these things are available, and this I have to build. So yeah, but you are
And I
going
have
on the right
another
direction.
question, or I have a request. Will there be any follow-up meetup on deploying NLP solutions
I
in live?
continuously do. I continuously do a lot of sessions. Yeah, but if that is a request, I can tell Vivek and take some session after some time.
Thank you.
Why not? Yeah. Okay, I think somebody else was also asking something. Sandeep?
Yeah, sorry, I may be asking silly questions.
No
The
worries.
purpose, I did
Nothing
a
is
little
silly.
bit clarification. Was the solution of this notebook searching few words from speech to text conversion, or what was the
No, this
problem
notebook is
statement?
just a simple classification problem, Sandeep. But speech, I mean, here there is no, I'm not using speech to text or anything. But let's say, I mean, that is not a very by how it sounds, it is not so complex. There are some libraries like Pi Audio and all this. You can use them, and I probably I'll take some session later where I'll speak and I will show you that it is getting converted into text, everything. So so that is like, and on the once it is converted into text, you can do the same thing that we have done. You can apply classification, you can do search, you can find how many words I spoke about NLP, how many times I spoke NLP. We can do all these analytics. I'm just giving you a scenario, but this is possible.
What did we do in the notebook?
We basically did a classification of news classification. So there are many newspapers that
Okay.
is like, say, news articles, which is sci-fi related, business related, like which category it belongs to.
Okay.
So that is what we did.
Thank you. Thank you. Got it.
I took a simple problem. I mean, I could have taken NER or I could have taken something complex, but there are so many things here. Spark, NLP basics, and different varieties of folks that join the session. So I can't really make it too complex, but sometimes it is focused towards a specific problem domain, like let's say speech to text. I have taken sessions earlier also, and I will be taking later also as we are collaborating with Vivek. And that time you can definitely join and see some problems which are focused on that areas.
Sure. Thank you. Thank you so much.
Yeah. Okay.
Okay, so a good session, Indrajit. Any other final questions, audience? So thanks a lot, Indrajit. A lot of detailed information about basics and advanced of NLP, along with Spark NLP, of course. So thank you very much for your session. And I
Thank
can see
you.
a lot of audience engagement and questions came, which is nice. If you are interested in our other webinars, you can check our YouTube channel, which I have shared on the chat. Do try our AI platform, which has integrated projects. And we have a variety of courses and internships as well. And look forward to future sessions from Indrajit. He has been doing quite a many and will keep doing more. So I'm confident of that. So looking forward to that.
Yes,
you
sure.
all.
Thank you, Vivek, and thank you, everyone. I'll share my LinkedIn if anyone wants to connect.